surrounding medium. So by virtue of having a very long carbon chain surrounding the particle, that's also going to impact your plasmonic resonance. So our approach was to do a single particle measurement where we could look at the surface plasmon resonance and then correlate it with the size and shape of the particle. So to do that, we relied on electron energy loss spectroscopy, a rather old technique on the one hand, but a technique that only in the past couple of years has given us atomic scale resolution and very high energy resolution to do spectroscopy. So the basic idea is that you focus down an electron beam to a small probe size with dimensions on the order of about 0.25 nanometers. You pass it through your sample, which is on a thin electron transparent film. It can be carbon or silicon dioxide, silicon nitride. And then when the electron beam interacts with your particle, it excites the modes of the particle, including the surface plasmon resonance and also the bulk plasma resonance. And in exciting those modes, the electron beam loses some energy. So what we're detecting in these measurements is the electron energy loss as a function of energy. So the cool thing about electron energy loss spectroscopy is we can not only get very high spectral resolution, but we can also get very high imaging resolution. When we're not in STEM mode and we're just in wide field TEM mode, we have an imaging resolution of 0.07 nanometers, so sub-angstrom resolution. And just to give you a flavor for the resolution capabilities of the aberration-corrected TEM, here are some of the silver nanoparticles that we synthesized. In this case, they have sizes of about 11 nanometers down to about 1 nanometer. Importantly, to overcome the effects of ligands that might otherwise shift or dampen out our surface plasmon resonances, we used a colloidal synthesis that's free of organic ligands. So that way we not only damp out the plasmon resonances, but we don't have to worry about contamination in our TEM measurements. So now we switch over to STEM mode, and let's look at the spectra.